Hello, everyone, and welcome to our webinar, Carbon Management in Construction Products. We welcome all attendees from all over the world, and I hope everyone is doing well and keeping safe. This is Anne-Marie Pizzatelli, and I'm the Global Head of Marketing Built Environment for BSI. Measurement and management of greenhouse gas emissions has taken center stage in recent years as countries and industries have adopted ambitious climate mitigation goals. Because activities associated with construction and operation in the built environment consume vast amounts of resources, energy, and land, and produce 25 to 40% of global carbon emissions, this presents an enormous opportunity to impact progress towards climate change mitigation goals being enacted throughout the world. This presentation will serve as an introduction to the topic of carbon management of construction products. I would now like to introduce today's speakers. Keith Bryan is the Director Built Environment at the BSI Group. Keith leads the built environment sector for BSI Americas, representing the full BSI portfolio of products and services for clients and stakeholders. He offers a variety of experience integrating holistic solutions for the built environment, including greenhouse gas, accounting, climate change risk mitigation, energy efficiency, resilience, environmental social governance, ESG, and green building programs. Prior to government consulting, Keith worked for the U.S. Green Building Council, the USGBC, as a program integration manager for the certification operations team, where he was responsible for the strategic development of certification platforms for existing and emerging USGBC certification programs. Daniela Meyer is a partner manager and climate tech specialist at Procore. She is focused on building climate tech partnerships and bringing the value of Procore's partner ecosystem to market. Her background is in geography, urban planning, and smart city technology. She holds a Master's of Global Policy and Economic Development from Boston University. Please welcome Keith and Daniela. Hi. Hi.
Hi.
Nice to see you both. Just some webinar logistics. Our webinar will run about 60 minutes today with some time for Q&A at the end. You have joined a muted webinar, so you should be able to hear us clearly. On the next slide, if you would like to ask us a question, please have a look for the question box and type in your question. We will do our best to answer these at the end of today's webinar. If you cannot hear us, please let us know using the question box, and we will then support you and get you to hear the webinar. All of our participants today will receive some featured handouts, some really great ones, including our sustainability report from BSI, a green print for the sustainable built environment, plus our ever popular little book of BIM. However, you must complete the post-event survey in order to get the handouts. I will give a reminder before the end of today's webinar. We do have some polls today in the webinar, so I encourage everyone to take part. It's a great way to engage with others on the webinar and gain insight as well. These polls are coming up right now, and I will launch the first poll. So here is the poll number 1, and I will launch this one. And the poll question is, what industry are you in? Please select 1, designer, architect, construction engineering, product manufacturer, owner, manager, consultant, other. If you are other and your industry is not indicated, you can please indicate that in the questions box, and we will take a look at those. So I will give you all a minute or so to collect the responses. We're now collecting the responses. So I'll give everybody 5 more seconds. So in 5, 4, 3, 2, and 1, I will now close the poll. So please vote. And I close the poll now. And let's share the results. And it looks like we've got quite a few people that are consultants or other. Interesting. We've got a nice group of construction engineering, 30%. We've got some design architects, 6%, 11% product manufacturers, and 4% owner managers. Great, very interesting and wide range of audience mix today. Thank you. So now we're going to go to our second poll. And we're going to go to our second poll. And our second poll, which I will launch now, is How familiar are you with the topic of embodied carbon? And please select one of these following choices. I don't know anything about it. I've heard about it, but I don't know much. I am familiar with the basics, or I work with embodied carbon regularly. So let's just give everybody a few minutes, a minute or so to vote. I see we are collecting responses. Interesting results, and I will share the results in a few seconds with everybody. So please take the time to vote and let us know how familiar are you with the topic of embodied carbon. Great, and I think most people have voted, so I will give you 5 seconds and then I will close the poll. So in 5, 4, 3, 2, and 1, I will close the poll and I will share the results. Wow, it looks like a lot of people are familiar with the basics, 47%. A nice group, 45% have heard about it but don't know much. Well, that's great that you're joining today. Small group don't know anything about it, and a small group have worked with carbon regularly. So great results, interesting range of responses, and I thank everyone for voting and participating in our polls today. Thank you very much. I'll hide the polls now, and I will hand it over now to Keith and Daniela. Thank you.
Great. Thank you so much, Anne Marie. And thank you to everybody for joining our webinar. And a special thanks to Daniela for joining us here at BSI to discuss embodied carbon today. So first thing I always like to do whenever we start a webinar is just get an idea of who's attending the call, which is why we do those polls. So good to see a good mix of both knowledge and demographics there. This should be a good high-level overview, and then we can always dive in future webinars, or if you have specific questions, we'll have our contact information at the end there. So welcome to everybody, and welcome to Daniela.
Thank you.
So first thing I want to do is just give a general overview of what embodied carbon is, why it's important, why we're even having this discussion here today. So you may be familiar with the concept of the COPs. COP26 was just last year, and leading up to this COP, as you may know, in 2015 the Paris Agreement came out, and all countries agreed to put forth something called a nationally determined contribution, which is how they can have an impact on the level of carbon emissions for their particular country. So those were aggregated in 2020, and then when COP26 happened in 2021, there was discussion on where we currently stood, what we needed to do in order to improve things going forward. So this graph below kind of indicates where we are. So if you look at sort of that red area there, you'll see that's where we currently sit if all the nationally determined contributions were implemented as they were stated by the countries that participated in COP26. So as you can tell, we are scheduled to, or they're expecting us to peak emissions just after 2030, which is good. Of course, the negative to that is that yellow line of expected progress after that doesn't decrease very quickly, right? So if you look at those blue or greenish sections down below, those are our targets in order to be completely free of carbon emissions and keep global warming to a 2-degree maximum, or 1.5 degree Celsius maximum, right? And we are not anywhere on track in order to do that after 2030. So there is urgent need to implement other measures in order to make those NDCs more closely align with some of those carbon pathways shown down below. So that's the general overview of carbon emissions on a global scale here. So coming into more of a focus on buildings specifically, now this graphic is a drastic oversimplification of the topic at hand, but I like to start simple, and then we can make it more complex as we go. So generally speaking, over the life cycle of a building, there are two types of carbon emissions, right? The one that most people are familiar with and the large focus over the last 15, 20 years has been operational carbon emissions. And that's all the things that you're familiar with. So energy usage, water usage, materials, things like that. So all those energy efficiency measures that you put into place when you change out light bulbs or ballasts or change your HVAC equipment, all that sort of thing fall under operational carbon emissions and the reductions thereof. So that's important, but that's not what we're here to talk about today. The other 50% are what's known as embodied carbon emissions. And we'll get into the details of what this encompasses and whatnot, but largely speaking, this is the materials, the processes, transportation and whatnot of the construction of the building itself. So Danielle, I'll pass it over to you for this slide.
Thanks, Keith. So yeah, just going off of what Keith said here, really to take a bit of a step back and talk a little bit about the global impact of the built environment. There are so many different ways that we can measure this global impact, and carbon or greenhouse gas emissions is the one that we've landed on so that we can best target and really combat global warming and climate change. And of that, as Keith mentioned earlier, we have the building operations or operational carbon and building materials and construction or embodied carbon. And together, the estimate is these emit nearly 40% of all global emissions. And that's a huge amount. However, today we're focusing on the building materials and construction. So what that really is the supply chain of construction. And this is 11% as an estimate. However, in my work, I talk to a lot of different actors, external and internal, around embodied carbon, professors, researchers, and specialists on this topic. And everyone's leaning towards 11% being a gross underestimate. And the reason why is because embodied carbon is actually so much more than really the sunk cost of a building before it's operational. And so the reason why it's so hard to track and why we say 11% is because we don't have accurate visibility into all of the market players that are involved in measuring embodied carbon. And this can be from, manufacturers of building materials, of all different types of building materials, to specialty trades and the MEP industry that like electrical, manufacturing, plumbing. And these can range from multinational corporations to mom and pop shops, which make it really hard to measure. So we're going to talk more about that today and hopefully get you guys to understand how to measure and reduce embodied carbon from your vantage point in the industry.
Absolutely. So now we just want to turn to just some of the primary sources of embodied carbon. So, like I said, most people are familiar with where operational carbon emissions come from. So this is just a high-level skim of what we're looking at when we're talking about embodied carbon. So on the graphic in front of us right now, this is a description of the built asset life cycle, right? So everything from the extraction of raw materials all the way through the end of a building's life, either deconstruction or demolition, and then waste processing there. So all the aspects that are shown there in yellow are embodied carbon emissions, whereas the aspects in blue or light blue right there in the middle, that's what we know of as the operational carbon emissions. So as you can see, there are many more touch points for embodied carbon emission throughout the life cycle of a building, and therefore many more opportunities for us to have impacts on those life cycles and those ultimate emissions. So turning it back over to Daniela to talk a little bit more about some of the specific topics within each one of these life cycle areas. Over to you.
Thanks, Keith. So this graphic really represents a lot of what Keith was talking about too, just a little bit more detailed visually to show that the embodied carbon is, as he said as well, from the manufacture and extraction of raw materials. But it's these little points in between that come together to make up the whole of embodied carbon emissions. So from the equipment used in the mining and extraction process, to the transportation of the raw materials, and then the manufacturing and the electricity used in the manufacturing process. And then different types of materials like concrete, namely, in just the creation of concrete emits carbon dioxide as well. And then there's the transportation of those building now products to usually a material supplier, and then from that material supplier to the site where the construction installation process happens, and emissions on site can be from equipment like cranes, caterpillars, and loaders, and then also fuel or electricity and water used on site in the construction installation process. And then when you go to operational carbon, a lot of people, say that operational carbon will be reduced over time because it is ultimately energy from the grid. And as the grid becomes greener and less reliant on fossil fuel energy, that will be reduced. However, inside a building, you can also improve the systems to reduce the operational carbon, like namely the water boiler, or improve the HVAC systems so they're operating more efficiently as their sources of operational carbon as well.
Great, thank you so much. So now that we've got an idea of what sorts of things emit embodied carbon and where we can start to look for that, we start to look at how we're going to measure this sort of thing, right? So when you're looking at operational carbon, it's pretty straightforward, but it's not as well known how to do this with embodied carbon. So typically speaking, the go-to measurement for embodied carbon is something called environmental product declarations. And these are a culmination of a few different approaches. There's a couple ISOs that are involved there, primarily revolving around life cycle assessment of the materials and the emissions of those materials. So that all goes into the EPDs, which are essentially estimates, depending on what level the EPD is formed at. It's a better or worse estimate, but we're not touching on that particularly in today's webinar. And then you can actually roll that up into an ISO, which is 14067, about carbon footprinting of products. So from there are also different implications as far as the life cycle of a building itself. So there is a British standard that was produced by BSI, British Standard 15978, that talks about these various different levels of emissions throughout the life cycle of a building. This is actually a screenshot of one of the graphics coming out of that standard, which if you know what you're dealing with, this is a pretty thorough graphic. However, it's not necessarily the prettiest. So I have huge congratulations for the New Buildings Institute for making this much more digestible, which is what you're looking at on the screen right now. So as you can see, there are various forms of emissions throughout the building life cycle. This is covered in that British standard. But on the screen here, you can see some of the ways that you can both start to measure and to reduce embodied carbon throughout the life cycle of your building. So moving over to Daniela to talk about some of the history of carbon reporting and life cycle assessment. Back to you.
Yes, thank you, Keith. I like to throw this in here to mention that, climate conscious building isn't a new concept, and that we as, human beings in society have developed according, in low environmental impact. And there have been great examples where, we've gone above and beyond in, making a building very sustainable and resilient. However, it's not always the standard, right? So where things really came into play and is with LEED, which is leadership in environmental and energy efficiency standards, essentially. And there's a ton of other certifications out there, as well as standards that helped popularize energy efficient building. And it was actually in LEED that the environmental product declarations became more popularized to measure building materials based on the global warming potential, which is the carbon emissions. And so LEED, became a standard and went live with the World Green Building Council in 1994, and today it is most known in the green building standard and certifications. However, there are others like WELL or FitWell that base it more off of occupants' health, and then there's even more new, really ambitious ones like the Living Building Challenge that have a variety of petals to achieve. But this has been really helpful and has been also used as a marketing tool for a lot of owners to prove that their buildings are sustainable and resilient. However, they're a huge administrative burden on the contractors that are going through them. And so over time, while a lot of buildings are still built to the LEED standards, they're not always going through with the administration and certification process to stamp that plaque on their building. And over the past several years and today, Architecture 2030 has really popularized the focus on carbon emissions and the net zero goal, or achieving neutral greenhouse gas emissions. And this can also be translated in a marketing way with trying to produce a net zero building. However, as we're talking about here today, literally no building or product will ever be truly net zero without offsets, because it takes carbon emissions to produce the building products and to construct the building itself. And so sometimes net zero goals can be misleading as to truly how committed the builders and owners were to sustainability goals in the process. Where we see the industry really going is with data and insights. And the construction industry as a whole, and manufacturing of building products included in that, and even real estate of existing, operational data of existing buildings, is really low-hanging fruit. We're in the early stages of really capturing the data that we can derive insights from and improve our built environment. We're also seeing a lot of emerging regulatory pressure. One example in the United States is the SEC that has proposed all public companies report on scope 1, 2, and 3 greenhouse gas emissions, as well as climate risk. And we're also seeing a lot of goals from various countries and multinational corporations to achieve net zero goals. This is spurring the urgency to be able to track this and where we really see things going. You can go to the next slide. However, there's a huge challenge here. I love this quote from the Carbon Leadership Forum, great organization, that says, although there's a growing need and recognition of the need to track and reduce embodied carbon, building industry professionals need better data and guidance on how to implement low carbon methods in practice. So this is really telling that we not only need good technology solutions to capture embodied carbon data and all the processes that go along with it, but we need more industry professionals that are focused on green building, green methods, and it is really the coupling of the two, good data and committed sustainability professionals, that we can help transform this industry to reduce its environmental impact. This is how to start embodied carbon tracking. So this graphic that you see here, it's very similar to actually the graphic that Keith was showing earlier in the different stages. It just spells it out a little bit differently and breaks it down into each of the sections. But this is from the World Green Building Council. And it's from their actually report on bringing embodied carbon up front. And not ironically, where I often talk to different external people in the industry and various companies is where to start because it can seem like a very overwhelming process to track all of the embodied carbon of all of your projects and your own carbon emissions from your buildings or your operations. And so where we say to start is really just with upfront carbon, and just take off one little bite, one step forward. Where this comes from is in the stages of A1 to A3. That is the entire environmental product declaration process that Keith talked about earlier, that BSI has various standards around. And there's several different types, as he alluded to. Some of you who may be more knowledgeable about this subject know that there are industry environmental product declarations as well as specific product environmental product declarations. So some are giving more of a larger range of an estimate, others are more specific. Obviously, we want to get to the most specific possible, but we'll take what we can get in the near term. And so that is the A1 through A3. Primarily responsible parties are the manufacturers themselves. And then you go from A4 and A5, which is the actual construction installation process. And that is about tracking the transport of materials to the job site and understanding where they're coming from and how far they're traveling. So for example, say you want to choose an extremely low carbon material and of carpet, for example, but it comes from India and your project is in California. That's probably not the best solution to actually achieve an overall lower carbon emissions. So it's a combination of choosing a low carbon material that is also geographically near where the site is for transportation purposes. And then you can also track the energy used on the job site, and this is from equipment, like I mentioned earlier, like cranes, caterpillars, etc., to the electricity and fuel used and the water used on site. As a bonus, but not really a bonus, I also suggest tracking waste on the job site. And this is also a byproduct of your whole tracking materials process. So if you can effectively track the materials on the front end, materials that come onto site, and maybe you have to order more materials because you hit a water table and need more concrete and steel, then it's beneficial to track the materials there. And then the materials that you don't use, you can determine as waste and either recycle them or responsibly dispose of them. And so that's where I suggest everybody starts as the bite to take off, and don't worry about the rest of it right now, because just tackling the upfront is a huge challenge in itself and a great place to start.
Absolutely, thank you. So now that we've kind of covered a little bit about how to get started on the measurement of embodied carbon, the next obvious step is, once you have begun the process of accounting for what you are currently emitting, the next thing is to figure out how to reduce that. So if you look at the world of operational carbon, I would say there's a fairly good blueprint as far as how to reduce emissions on the operational carbon side, right? So this is something called the energy efficiency pyramid. And I don't expect you to read everything that's on the screen right now, but essentially, as you move up the pyramid, both the amount of effort and the cost associated increases, and then the impact tends to decrease, right? So this is pretty well understood, at least as a path going forward from the operational carbon side of things. Now, moving over to the embodied carbon emissions, we also have a path forward, but that path is really more of a cycle. And I'll turn it back over to Daniela to kind of talk through some of those cyclical processes.
Thank you, Keith. Yeah, so I really want to portray this as a cycle as well, because I think just starting off in this concept of the life cycle of our buildings and our infrastructure, we should be viewing them maybe more like organisms than like static structures that we create and then then they suddenly disappear. So starting with the planning and design, this is the phase where you can decide truly how sustainable and resilient your building or project is going to be. It's to set those initial goals and depending on the budget or the ecosystem that you're in, maybe the energy sources that you want your building to have, and that's also dependent on the geography, maybe environmental risks of the site you're looking at, depending on various climate change projections. Maybe it's, in Miami and you want to consider various things there, or in a very cold environment. You get the point. But this is also the place to do carbon assessment, scenario planning, and more. And there's various technology out there as well and software to help with that process. Then moving on to the design and pre-construction phase, I carry over design into this one because you might have to iterate on the design when you're doing this pre-construction process. And it's the time to analyze that design and maybe reduce the use of concrete and steel where possible. What other things can you do? What other materials could you use in place of that? And then maybe you also have to alter some things due to those decisions. And this is where you can also make very specific building specifications based on the environmental product declarations that we talked about. And it's ensuring also that your design, your pre-construction, and your procurement teams are all aligned in this process. And also partner with your material suppliers and various specialty contractors on your carbon reduction goals so that they're aware that this is important to you. And then leveraging modeling tools like BIM or various energy modeling tools as well. Cove Tools is one that I know is pretty new and hot on the market to perform this kind of carbon analysis or life cycle assessment, which are also tools like Tally or One-Click LCA. Then moving on to the construction and installation. This is mostly just, use best practices on site with a well-trained team. It's also important in this phase to leverage tools for efficient communication between your teams on site, between your contractors and those in the office to minimize mistakes so you don't have to order more materials, which will then increase your embodied carbon emissions. This is also the phase to track your material deliveries and track the energy used on site, like water and fuel, which can be done either by collecting utility bills from your specialty contractors or perhaps using a metering system on site. Also recycle unused materials that you can. I know some materials are not so valuable on the resale market, and that's fine, but try if you can. Steel is primarily one that is reusable because it's valuable, right? And then try to do the most responsible waste disposal that you can. And this is the phase that's really important to collect that data that you can, because then you can make improvements on it on future projects. If you can analyze various mistakes that you made or areas where you were like, okay, we actually had to order a lot more materials on this project. Why was that? And to really get into it with that data and insights. Transferring on over to the handover and facility management. For owners too, it's really important to collect and keep that construction data accessible from the design and construction phase, so that you can ensure that all the equipment put in the building is performing efficiently and can find that information and know exactly which equipment to repair if you need to, and replace when necessary to make sure that your building's operating as efficiently as possible. And then in this phase as well, through material management, this is why I have the cycle. It's really good to just continue to improve the design of your building over time and improve your structure, make changes to it when necessary. And if you have a historic building, you're going to want to probably keep the facade or change various other things. And that's when leveraging consultants and others in the industry to help with that process is really important. So you're maintaining the integrity of the building and the cultural history of it as well.
Wonderful, thank you. I also realized that there's a slight mistake in the top left here. This is supposed to say reducing embodied carbon, not the operation of carbon. So I believe that mistake is on me. Thank you for the wonderful overview there, Daniela. So as you're starting to focus on what types of materials, this is one instance where there are certainly quick wins to be had. As Daniela mentioned, the focus of this, although you could certainly do an EPD for every material in your building, there are some primary emitters in construction, right? So she mentioned concrete and steel. Those are certainly the two largest, and there are alternative materials. There's ways to design out portions of that, both structurally and otherwise. And then there's also other opportunities to look at either replacement materials or just alternative design concepts in order to get rid of some of the embodied carbon for things like your insulation and your windows, your glazing, finish materials, either by changing them or just removing finishing materials altogether and just finishing concrete and things of that sort. So your quick wins are going to be in the concrete and the steel world here, but these are sort of the top five, I would call it, of material substitutions and design changes that can have a big impact. But ultimately, what you're looking at whenever you're looking at carbon reduction planning is to look at it within the bounds of the entirety of your building operations and construction, right? So from BSI's perspective, we have something called a decarbonization roadmap, which helps people kind of walk through that process and see, as mentioned on those graphics earlier in the presentation, see where you can have the biggest impact, see where your current sources of emission are, and see where you can make changes going forward. We also have a couple of other resources that we initially like to point people to, just as a method to get started. So BSI is not a construction company, so we're not going to have the same on the ground assistance that a construction company or somebody like Procore can help you with. But we do have something called the Carbon Reduction Hub, which is that high level overview of everything carbon emission, from net zero to just planning your carbon footprint to looking at where you can find opportunities for improvement. We even have a carbon reduction management planning tool developed by a variety of industry experts to help identify opportunities for your organization to improve there. So the links there, we'll send this stuff out afterwards. Also, Daniela mentioned just a few moments ago something called the Carbon Leadership Forum. They are an excellent resource for all things carbon, as you might imagine, but they also have something called the Embodied Carbon Policy Toolkit, which is what you see on the right side of the screen here. So this talks about everything from how you can impact embodied carbon through policies and procedures, all the way down to how you can design and reuse and construct, removing embodied carbon out of that value chain. So a couple really good resources to just help you get started. Like Daniela said, the hardest part is just really getting ramped up with embodied carbon and figuring out what it is that you even need to look at. And this is an excellent resource to do just that. Once you are in the world of embodied carbon and starting to look at optimizing your processes for calculating that, there are, of course, a variety of tools, and Danielle mentioned a few of them. On the screen here, we have on the bottom left, I have one of the sections from that Carbon Leadership Forum Embodied Carbon page. That is a specific Excel-based template. I find that template very easy to use to just, like I said, give you an overview of what sorts of things that you should be looking at and how to implement that in your construction process. If you're looking at something a little bit more automated, you might look to something like the EC3 tool, which is the Embodied Carbon and Construction Calculator. I'm surprised I got that out without butchering it. That is by the Building Transparency org, and excellent resource to both calculate and look at alternative materials. There's also things like one-click LCA, which looks at, as you might guess, life cycle assessment, including embodied carbon. There's tools like Tally, also for life cycle assessment. And then there's Athena, which has a variety of calculators and resources in order for people to get a better idea of the life cycle emissions of their products that they're dealing with. And that actually concludes the content. I do want to just give a quick overview of who in the world is talking to you today, just so you know what our qualifications are and how we can help you if you are interested. So from BSI's perspective, we are that higher level resource. So we are global. We've been doing this for about 120 years or so. We are the national standards body in the UK, the largest certification body in the world, one of the founding members of ISO. And we offer a variety of services, both around standards, assurance for standards, and consulting services to support all of that. And then Danielle, I will turn it over to you to give a brief overview of Procore.
Yep. So Procore is a primarily a project management software for construction, and our mission is really to connect everyone across construction projects from a bunch of different stakeholders together on a single platform to build smarter. And a big part of this is, we have a variety of tools kind of listed out here, but there's, even smaller tools in between. But from pre-construction all the way through to closeout, Procore's mission is to bring the stakeholders together and across the project lifecycle. So that's from the design phase all the way to closeout. We have unlimited users and support, and we integrate with a variety of solutions. I believe we have over 400 integrations on our marketplace to connect with your other systems as well, so that they all speak to each other. And our mission is really to bring data transparency to the industry, and so they can communicate better and produce projects on time and within budget.
Awesome, thank you. And a couple of those integrations are actually with embodied carbon calculation tool. So if you're looking for help with embodied carbon specifically, Procore can certainly help you out there. Okay, cool. So now we want to move on to just a Q&A session. So if anybody has any questions, everybody's on mute for this webinar. So feel free to type any questions you have into the question box or the chat box, and we can kind of take turns answering those as they come through. So Anne-Marie, are there any questions already in those boxes?
Yes, Keith and Daniela, we do have a couple of questions that have already come in. The first question is, what is your advice for how to get started measuring embodied carbon if we don't do it at all right now?
I can take this one. So I think the first part is really just understanding and educating your team on it, which you may not think is like fully tracking it, but I would start with the pre-construction phase. And so once you determine the materials that are going to be in the project, there are those variety of calculator tools that Keith talked about earlier that have what those carbon emissions, or it's referred to as a couple of different things, but it's the global warming potential of various materials, or the carbon intensity of those materials, to start tracking and saying, what the estimate of your project is. I would also caution here, though, that as a team, I think understanding first, like the types of materials that have the highest carbon intensity is the most important. And then the goal of this whole process should also be to reduce. So I would just caution to, not feel too overwhelmed with the analysis paralysis, and to just get started and to use those high-level estimates of what the materials emissions are, and then try to reduce the largest emitters like steel and concrete.
Yeah, I agree with everything you just said. I would also add that, like I mentioned earlier, it's important to understand embodied carbon in the context of the larger organizational goals, right? So I think it's very easy to dive into calculating and trying to figure out very specific emission amounts for each one of the products that you're dealing with or the processes that you're dealing with. And especially when you're dealing with embodied carbon, you can quickly go down a rabbit hole trying to get every last point of emission. And it has diminishing returns when you start doing that. So like Danielle said, there are some quick wins in the embodied carbon game. And if you're not doing those already, that's the place to get started and figure out how that fits into your overall carbon reduction strategy. So
I even just thought to myself too, I've seen actors in the industry, trying not to name names, but it's like I've seen actors in the industry just measure the embodied carbon of the superstructure, for example, as a starting point, rather than getting to the substructure and the interiors and all of the details. I think it's just important to start somewhere, and then as you get more and more comfortable with that motion, you can go deeper and more detailed.
That's right. So as mentioned previously in the webinar, one of the biggest challenges with embodied carbon at the moment is very similar to a challenge that we saw with operational carbon 20 years ago, which is that we just don't have the data to support really robust decision making, right? And as more and more companies start to get into the world of tracking embodied carbon, we will see improvement in both the processes to collect that data as well as the number of products that have that available, and we'll naturally be able to have a better idea of how to reduce embodied carbon, just like we did with operational carbon over the time. So
thank you, Danielle and Keith. We do have another question that's come in. After we get our embodied carbon results, how do we know how it compares to other buildings, if it's good or bad?
Keith, I can take it too, but you want to start?
Yeah, so similar to what we were just saying, I would not initially focus on whether it's good or bad. I would focus on progress, right? So essentially what you're doing when you take that initial measurement is creating your own baseline, right? And the goal here initially should be to just focus on decreasing from project to project, right? So if you can have material substitutions in your next project, great. If you can have process improvements in your next project, great. As we have more robust data available over time, like we just mentioned, there will be more of a case for benchmarking across the industry. But for right now, that's hard to do. So focus on benchmarking against yourself. And Danielle, if you want to add to that, feel free.
Yeah, I would agree. I would say that just benchmarking in this industry is extremely difficult because no project is the carbon copy of another. To use that euphemism. Every single project is different and has different conditions, is in a different geography. Even if in the same city, they could have different baseline conditions. So I would also echo what Keith is saying and say that these types of software tools that we've been mentioning here can help you determine how to measure those baselines. For example, you could estimate what the embodied carbon is of your materials if you didn't make any selections of new materials that had lower carbon. And then after you make those material selections, I know EC3 is a tool that does this pretty well, and it even exports after you use the EC3 tool and select materials with lower carbon emissions. It says like how much you saved by selecting those different materials with the same specifications. And then you can even go further and say that, okay, so there was our first, this is our better, and then measure what the actual as-built embodied carbon is on the project. And this is okay to say that this is likely going to be more than what you estimated in the beginning, because things change on the job site. Sometimes mistakes happen. You have to order more materials. maybe the material that you selected wasn't available, and so then you had to go with a different one. And all of that is not to be, punished or say that you did a poor job, but to say that, okay, we're trying to track these different things. And so maybe the end goal is to try to have the end as-built carbon emissions as close to your better estimate as possible, is where I would say starting with benchmarking.
Great. We do have another question that's come in from Sophie. Can low carbon concrete provide the same structural qualities as normal concrete to encourage wider use?
When you say low carbon concrete, I think that the answer is just broadly yes, and it just depends on the specifications for what that particular project is seeking for the use of that concrete. And there's even, I've seen concrete manufacturers that have it's like precast concrete, where they can capture the carbon from the manufacturing process and then insert it back into the precast concrete, where I would say, yes, that one's a great one and more advanced. But that option, for example, isn't available for pour concrete. So it just, I think, depends on the use of the concrete for the project and what those specifications are.
Great. I think we have time for another one. This is from Kelsey. Are there laws and policies in place for embodied carbon in construction, and what level are and at what level are they enforced?
The shorter answer I would say is no, not specific to embodied carbon. However, there are carbon emission general laws and policies, right? So previously in the webinar, Danielle mentioned like the SEC proposed rule, right? So the SEC proposed rule is that any company that has declared their greenhouse gas emissions must publicly report them, right? So as you are reporting your carbon emissions, it's going to have to be accurate, right? And that's going to have to be a reflection of not only your operational carbon emissions, but also your embodied carbon emissions, right? So so yes and no. I mean, it is included in the larger scale, but most actual legislation that refers to emissions is talking about operational emissions in the form of energy efficiency or water efficiency or something of that at this point.
I can also mention, I don't know, I'm not aware of the international ones, but I know that, for example, a lot of European countries are cracking down on this. And the way I see these policies shaping up is similar to in the United States and California. There is a state policy there called like Buy Clean California, which is about purchasing certain materials that have a lower carbon intensity. And so the policy itself isn't regulating the embodied carbon emissions of the end result of the building, but it is regulating what a subcontractor or contractor is allowed to purchase when it comes to the material emissions. So it's in a roundabout way. I would say that the Buy Clean California one is regulating embodied carbon emissions, but the target is coming down on the manufacturers and the purchasers of the materials, and not on the end result of the project reporting.
Yeah, so I agree. I think it's all in how you frame that question. So, like, are we currently seeing in legislation the words embodied carbon? No, not really. But we are certainly seeing things that encompass that.
Yes.
Great, thank you. I think we have time for one more question from Vishali. You may have answered this, Keith, but just again, as a person who doesn't know how to measure, how can we exactly calculate it for each product?
Yeah, so if you're looking to calculate it at the product level, one of the first things I would do is go check to see whether that product has an EPD. And if they do, then that's how you get started. You measure the amount of the product used versus the amount of emissions stated on the EPD. Like we mentioned, that is somewhat of an estimate. Right? So you're going to get close, but not perfect, and that's okay to get started. And sorry, did you have something to add? Go ahead.
Yeah, I just want to add here too that I understand the desire is obviously to get as specific as possible, and that is a great goal. However, it's important to pick the low-hanging fruit of reductions that we can, and maybe we know that using less steel and concrete will reduce the embodied carbon, and so aiming for that as well as trying to get as specific as possible should be part of your strategy initially. And then as well, because actually getting to a very specific carbon emissions of certain products, that doesn't always exist for that product. For example, because we have like the industry environmental product declaration, which is a general one for a general product, and then we have like the manufacturer specific product as emissions. And so where I'm going with this is that I think the most powerful thing you can do as a sustainability professional is not spend your time getting as specific and detailed as possible, but to go out and to educate your material suppliers, your manufacturers, warn them ahead of time, you want this, you're asking for it, and tell them how they can track their emissions so that we can get as specific as possible. So yeah, I just want to thank all the people that came to this presentation today to learn a little bit more and to leave you with the most powerful thing you can do as an individual is to spread the word that we need to track this, we need to get more specific, but the focus should always be on the reduction of it while we get more detailed over time.
That's 100%, and I concur, and that is something that you might not be able to control, your supply chain or your value chain, but you certainly have influence on it. So you can, if you go to that Carbon Leadership Forum page that I mentioned, they'll have information about things like purchasing policies and how to talk to your suppliers and things of that sort. And that overall, over time, will help make a more robust data availability and help everybody in the market do better.
Great. Thank you, Daniela and Keith. We still have a lot of questions. We can't get to them. I'm sorry. A lot of questions came in, but if we didn't get to your question online, we will get to your question after the webinar through Keith and myself, and we will get back to you. Sorry about we can get to all the questions. At this point, I'd like to thank you all for attending today's webinar, and thank you to our speakers, Keith and Daniela. Great presentation, so much fascinating information. All participants today will receive a link to the recording of this webinar, as well as links to the featured handouts, the sustainability report, a green print for the built environment, our great little book of BIM, and other materials. However, in order to get this great content, you must complete the post-event survey that will pop up as soon as the webinar is finished. If you have any questions regarding sustainability in construction, BIM, verification or kite mark training, certification or consulting services, please indicate that on the survey and we will get back to you right away. Once again, thank you so much for attending, everyone, and have a great day. Thank you. Bye-bye.
Thank you, Daniela.
Thank you, Daniela. Thanks, Keith. Bye-bye.
Bye.